Alrighty guys, welcome. Here we go on the remainder of this packet. We're doing 14, I think it's to 22. I think that's how many we did on this guy. Yeah, 22 total. So you're going to want to be able to use a calculator or your buddy Wolfram Alpha on this one. So I will be going up to that Wolfram Alpha a little bit later just to remind you how to do these at home if you need to. But we're going to practice using the calculator as well. Anyways, so what makes this section of the packet different than the previous section is this word right here, continuously. Whenever you see that word right there, continuously, it immediately means that you must be using our letter E formula. F of t equals A naught, which stands for initial value, multiplied by E to the RT. Please note some other books use a lowercase a, some other books use a K instead of an R. They all mean the same thing. And really, once we have all three of these variables over here, we could just plug and chug and we're done. Sometimes you need to solve for something though. So let's check out this problem. Amanda invests $3,957 in a savings account. So immediately, that's telling you that the initial value in the account, the A naught, the amount at time 0, is $3,957. Then it says an annual interest rate of 5%. So R is therefore 0.05. Be careful with that. Some people put 0.5 by mistake. 0.5 is 50%. So remember, what we're doing is we're doing 5 divided by 100. That's what's happening there. Doing it over 100. Moving the decimal over 2 times. What will the account balance be after 5 years? So after 5 years, that means that T equal to 5. And we just plug all this in. F of 5 is 3,957 times e to the 0.05 times 5. And we just need to use our calculator to actually figure out what this number is. So this is approximately, and we're going to take our calculator out. So on our calculator, what we're going to want to do is type in that 3,957 there, multiply it by, and the button that we need to find is actually right here. It is that blue E right there. So we'll hit seconds ln, and that's going to give us the E raised to that power 0.05 times 5. And there you go. It tells you we got $5,080.89 if we round up. Now, if you're at home and you don't have one of these calculators, what are you going to do? We're going to go ahead and use our Wolfram Alpha. So what Wolfram Alpha is going to do for us, I'm going to go ahead and open it up here because I need it on, I need to put it on a separate screen. It's going to be a second. I got to do this whole transition thing. Oh my gosh. Here we go. And transition over. Alright, so Wolfram Alpha will do all this work for you. We need to type it in as it appears on our paper. So it was 3,957 multiplied by, a little star for multiply, and then E raised to. And the only thing that's different here is when you use the E to raise to, you have to put parentheses, anything that's in the exponent or Wolfram Alpha won't quite get it right. So 0.05 times 5, and then just hit, and actually kind of highlighted the answer there in advance. I didn't need to, but it tells you it's 5,080. It tells you what it is, and it gives you all sorts of other cool information about it if you needed to. Don't need to worry about it all that much. So let's go ahead and turn this guy off and transition back. And I'll show you how to use it for other problems. And actually, interestingly enough, it'll literally solve other problems for you if you feel like it. Let's do number 15 now. So Mofor invests 1,962 into a savings account with a fixed annual interest rate of 8%. So same exact idea because it says compounded continuously. And when it says this continuously, that means our initial value here is going to be 1,962. Means our rate here in this problem is going to be 0.08 because that's 8 divided by 100, moving the decimal over twice. But we don't know how long, so we don't know what t is in this problem. Instead, we're given that f of that value t is equivalent to 3434.82. So we actually need to solve this equation for us. So solving this equation, what we actually need to do is set the entire thing up. So we're plugging this guy, we're replacing it for here. We're setting this equal to A naught, the initial value 1962. So again, all I'm doing is I took this here, replaced it up there, took to A naught, I'm replacing it there, E to the R, and T is the thing that we don't know. And now we need to solve this equation. So we want to go ahead and divide both sides by 1962. And when you do that in your calculator, 3434.82 divided by 1962, you end up getting 1.75 equals e to the 0.08 t. You just want to make sure you store that number in your calculator. You know, store it to the letter c or something like that. You don't absolutely have to, because all you have to do next is ln of that number is 0.08. That is our log loop that we've been working on for quite a bit. So again, it's saying that e raised to this power over here is the inside, and that's actually exactly what that above statement is. Finally, divide both sides by that 0.08. So we have the ln of that 1.75 ... divided by the 0.08. Whoops. So doing that on our calculator, how we actually want to do this, we have that 1.75 that I just did, but you want to store it to a letter so you can do the rest of the question accurately. So to make that happen, we're going to go ahead and hit the store button, which is right here below the ln. When that happens, this guy shows up a little arrow, and we're going to pick a letter. It doesn't matter what letter you use. I am going to use the letter, how about letter A? There you go. And to get the letter A to show up, I hit alpha and then math. The letter A shows up. Now I just need to do the ln of my little a. Don't forget to end the parentheses and then divide by 0.08. Alternatively, you could have also hit alpha y equals enter and then done the ln of a divided by 0.08. That would have been okay too. Either way, we're clearly getting 7. So that means in this question that t equals 7 years. All done. That was a really weird R. Let's continue on and move on to number 16. Oh, actually, before we move on, I want to show you that Wolfram Alpha will actually do the entire question for you in the event that you wanted to do these. Like, let's say you're doing one of those web work assignments at home and you don't feel like doing the rest of this workout, you don't have a calculator with you, you don't want to do any of this stuff. Let's do this whole thing on Wolfram Alpha. It's our greatest friend here. So we're going to go back to this, transition back into Wolfram Alpha. Alright, cool. So we're going to type this in 3434.82 equals 1962 multiplied by e raised to the parentheses 0.08 t, end the parentheses and hit enter. And it literally just does it for you. It tells you right here, oh yeah, t is approximately 7. Interesting enough, step-by-step solution. If I click this button, it's going to ask me to pay for it. It's only $3 on your phone. So you could actually get this app on your phone and click it, and it will give you the same step-by-step solution if you really wanted to. I think the online one is more expensive, so I don't recommend that one. It costs too much. But I don't know, if you got $3 to throw at this guy, it's not the worst. Anyways, let's go back to our actual question. We're not going to do any more Wolfram Alpha today. Number 16. So JD invests 6691 in a savings account. So again, same stuff. A naught is 6691 with a fixed annual interest rate compounded continuously. So again, this is that continuously number we want. After 4 years, so t equals 4. The balance is 850593. So that means f of 4, so that's the t value that we wanted, is 8505.93. What is the interest rate? So we're looking for r. We don't know what that is. Question mark. Just set up the equation like we've been doing. So we can say 8505.93 equals and it's going to be 6691 multiplied by e to the r times 4. And again, our left-hand side came from this number. This is our initial value. E, we don't know what r is, and 4 is how much time we got. And honestly, this question is exactly the same as the previous question that we were solving. Divide both sides by 6691. I'm going to use my calculator to do that. 8505.93 divided by 6691. Do it on the calculator. Oh, you guys can't even see the calculator, but if you type it in, you get this cute little guy, 1.27. 1 dot 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 equals hard to write with that in the way, e to the r times 4. I'm going to store that to the letter a in my calculator, and then I'm going to do the ln of that a is equivalent to r times 4 and divide both sides by 4. And if you do this correctly on your calculator, we will get, looks like r is equal to 0.06 or 6%. Either one of these is full credit for me, by the way. I don't care if you write 0.06 or if you write 6%. Both are going to work out for me. And what I typed in the calculator is right there, you get that 0.06. Anyways, number 17. Dan invests a sum of money in a retirement account with a fixed annual interest rate of 6% compounded continuously. After 13 years, the balance is this guy. What was the initial amount? So this time we actually don't know what A naught is. We do know that our rate is 0.06. We know that T is 13, and the F of 13 is 17,611.03. Setting up our equation, we got 17,611.03 is equal to E. Oh, it's not equal to E yet. It's equal to A naught. My brain, I'm sorry. A naught times E to the 0.06 times 13. And to solve this, we literally just divide by this guy and we're done. It's a whole problem. 17,611.03 divided by E to the 0.06 times 13 is equal to A naught. Type it in all into your calculator as accurately as you can. My recommendation is to use the alpha y equals enter button to get your fraction going there. And if you type it in, I'm not going to do it on screen, 17,611.03, and then we got E 0.06 times 13. And if you do this correctly, it turns out that your initial value in your account was $8,000, $8,073. I don't know why I said $8,000. $8,073. Moving on to the next type of word problem. Here we go. So solve each exponential growth or decay problem. I never use the word decay. Decay just means getting smaller. Technically, I did use it in one of the packets way at the end of it. I don't have it in front of me, but I used it. It just means getting smaller. It means this guy here. It means r is negative, if you want to say it, whenever you have decay. Anyways, let's read this problem. During the exponential phase, E. coli bacteria in a culture increase in a number at a rate proportional to the current population. So this is effectively trying to say it's 2%. Sorry, it's a exponential growth because it's exponential. If the growth rate is 2.7% per minute and the current population is 1960 million, will the population be 10.4 minutes from now? So again, we need our equation. I'm going to write it down just so we have it on this page again. So the growth rate is 2.7% per minute. So that means that we have R is equal to 0.027. And the current population is 1960. So the initial value is 196.0. And it wants to know 10.4 minutes from now. So the time is 10.4. plug it all in. 196 multiplied by e to the 0.027 times 10.4. I'm going to pause for a second, make sure that you guys could be able to figure this out without the word continuous. I guess it says exponential. When it says exponential, it's trying to say it's continuous. I think when I write the questions, because I had a computer generate all these problems for me, when I write the questions on my test, I'll be very, very certain to include the word continuous on there. But in the end, it says exponential, and anytime it's this exponential, it's kind of meaning towards e. All right, anyways, 196 times e, we're just doing this in the calculator again. So again, you should be doing it on Wolfram Alpha. If you don't have a calculator at home, using that calculator in class, make sure you're able to do it. If you get it, this is going to be equal to f of 10.4, which is approximately 259.54 million. Okay. A little bit annoying, but still doable. Let's keep it moving. Number 19. A cup of coffee cools at a rate proportional to the difference between the constant room temperature of 20 degrees Celsius and the temperature of the coffee. So again, it's the same exact idea. If the cooling rate is determined to be 3.7% per minute and the current temperature of the coffee is 76.1, how many minutes will the coffee cool to 49.9? So the key here is because it's cooling down and it's getting a lower number, that is talking about this r being negative. That's the hardest part about this question, is realizing that, because I actually haven't given you one like that in class yet. It's kind of why I'm making sure I'm going over this in the video. Hopefully I'll do it during class later too. Anyways, let's just keep on moving. So there's a couple of stuff throwing around here. We don't care about this 20 degrees. It's actually not useful in the problem because we're starting off at 76.1. That's our initial value. Our r in this problem is negative 0.037. And we don't know what time it is. We're looking for in how many minutes, so it's asking for time. And finally, we know the final amount, f of t, in this problem is going to be 49.9. Just got to set up the equation like we've been doing. So 49.9 equals 76.1. That's our function, is equivalent to the original value multiplied by e to the negative 0.037 multiplied by t that we don't know. Divide both sides, 49.9 divided by 76.1. And that's going to be 0.6557 about, ... You can store that in the calculator again. Equals e to the negative 0.037t. Same stuff that we've been doing. We want to do the ln of 0.6557 equals negative 0.037t. Divide by both sides by 0.037. Don't forget it's negative. And your final answer will be, I'm plugging into my calculator. Turns out if we do this work over here, I didn't write the last step. ln of 0.6557 divided by negative 0.037 is approximately equal to 11.4, and in the question looks like minutes. Not the end of the world, just got to keep on going. Keep it moving, keep it moving. We have all this during the exponential phase, E. coli. For some reason, this program really likes E. coli. I don't know what the deal is with that. So bacterial is growing. Again, the growth rate is 1.9%. Current population is 1111 million. What's the population 6.7 minutes ago? Ooh, that's interesting. I like this question. 6.7 minutes ago. So the reason why I like this question is it's almost identical to number 18 in that it's very, very easy to start and set up. So we got A naught is 111. We got our R is 0.019. And after that, we have our time. The deal is because it's a go, time is actually a negative number in this question. Because you want to go backwards for the time. That's the key there. So gives us that negative number, interestingly enough. Anyways, that means that f of negative 6.7 is equivalent to 111 times e to the 0.019 times negative 6.7. And plugging all this into my calculator. That's what a lot of this is. It's a lot of calculator work. And if you do it correctly, it is approximately 97.7 million. All right, easy enough. During the exponential phase, E. coli and the culture grow. If a population triples in 47.8 minutes, and how possible will it quintuple? So this is an interesting problem. We can do it in a lot of different ways. We can actually go back in time and do it the way I taught you quite a while ago. So I'm going to show you both ways, kind of the way that I'm expecting you to do it now and the way that it is before. The easiest way to do a question like this is to make up an initial amount. And in my opinion, the easiest initial amount that you could possibly think of is 1. Make an initial amount of 1. If they don't give you 1, make up the initial amount. It also tells you that 47 minutes later, that is to say f of 47.8, is triple. So if it triples, that is 3 times 1. And setting up the equation then. So we got 3 equals 1 times e to the r times 47.8. And this is going to help us solve for that r value. So dividing by 1 still gives you 1. So now we got the ln of 3 equals r times 47.8. So ln of 3 divided by 47.8. And if you do that in your calculator, you'll get that r is approximately 0.02298. Really want to store that as a number in your calculator for sure, because now it wants to know how many minutes will it take for the population to quintuple. So now you have to go back and do some more work, because you're asking what happens, how long will it take for it to quintuple. Quintuple, by the way, means multiply by 5. So we have 5 now is going to be equal to 1 times e, and then r is right here, times t that we don't know. So I'm going to write r right there. But r is at 0.02298. So we got the ln of 5 divided by, or equals r times t. Ln of 5 divided by that r will give us the answer. And again, I'm using the same r that we did in that previous part of the question. So ln of 5 divided by that r value, and if you do it correctly, it turns out that you get 70.03 minutes. Now, like I said earlier, there was an easier way to do this question. The easier way to do this problem was how I taught it to you back in December. So to go back in time, how we did this in December is that if it triples in 47.8 minutes, that means its growth factor, actually no, there isn't an easier way to do this problem, is there? Can you still have to solve for time? I lied to you, there's not an easier way to do this. This is as good as it's gonna get. My girlfriend's staring at me like I've done something wrong, terribly, terribly wrong. She's like laughing at me. Anyways, sorry guys. We're gonna move on to the last problem. It's 22. I'm getting too tired. It's 10:01. I want to sleep. You know.
Sure it's not just because you're stupid?
Wow.
Boom.
Um.
Roasted.
I'm not gonna give that
Dude,
credence.
that would be a teacher.
Oh, God. This is what I have to live with every day, guys.
Get
I hope.
off the stage. No one likes you.
Oh no!
Boo.
All right. The depression sets in, but not until we're done with this question. For a period of time, an island's population grows at a rate proportional to its population.
Who cares about
Population.
depression? There's always time for math.
Quintuples in 28.2 years. Okay, so this is actually just the same problem as last one, but faster. So again, you have to make up an initial value, make it up, and A naught is 1. The population quintuples in 28.2 years. Quintuple again means multiply by 5. So our f of 28.2 is equal to 5. So 5 equals 1 multiplied by e to the r times 28.2. Dividing by 1 keeps it a 5, so I can just do ln of 5 equals r times 28.2. And divide both sides by 28.2 to get what r is. And you'll get the ln of 5 over 28.2 is approximately, let's see, ln of 5 divided by 28.2. And you'll get 0.057, which is going to it could be 5.7%. Alrighty, guys. Good luck finishing this up. Have a great rest of your day, and I'm going to go cry myself to sleep. See ya.